Hi, it's Cyril from BS Tab 11 and today we're going to discover more things that happen likely or unlikely. We're math, we are dealing with concrete and established things where we are certain that that is the final answer. For example, if we say that Jessica bought 1 apple and 1 orange, then she would have 2 fruits in total. Or if we saw Anne having 2 oranges but by some strange magic she multiplied it by 2, so now Anne has 4 oranges. But that's not entirely what we're going to tackle today. There are things, especially in our lives, that we are uncertain about. Things that aren't always so predictable. And this is what probability will be talking. So probability is the measure of how likely something is to happen. For example, Jan had his whole life centered around tossing a coin to make decisions for him. The likelihood of the coin landing either heads or tails will be its probability, which therefore John would have half the chance of seeing his coin landing on heads or tails. In probability, we have 3 laws. The first law is the addition law. Let's say that I wanted to find the probability of the duck going the middle, left, or right road, or that I wanted to know the probability of my friend Harry drawing a spade or a face card. We can use the addition law in order to find these types of events. The addition law can be used when we're interested in finding out the probability of event A or event B happening, such as the duck going in the middle of the road or turning left or right, or my friend Harry drawing a spade or a face card. There are 2 events that we need to look out for. These are the mutually exclusive events and the non-mutually exclusive events. Mutually exclusive events are events that do not both occur at the same time. For example, the duck can turn left and say that, hey, I took the right turn, or I can roll a dice that has both 6 and 1 on it in a single row. Anyways, according to the addition rule of probability, we can find the probability of at least one of the 2 mutually exclusive events by adding the probability of the first event and the probability of the second event. So for determining whether the duck goes middle or right, we can calculate the probability of it taking the middle road as 1 out of 3, or it going right as 1 out of 3 and add them together, which is 2 out of 3, and there we have it. This equation works well because we're dealing with mutually exclusive events. Now let's look into the second example. Harry is my friend and wanted to find out what's the probability of him drawing either a spade or face card. This will be more complicated because we are not dealing with mutually exclusive events. This is an example of a non-mutually exclusive event. A non-mutually exclusive event states that an event can happen at the same time. Since our example is a non-mutually exclusive event, we need to add one more element in it. After we add the probability of event A and the probability of event B, then we need to subtract the probability of event A and B happening. So if there are 13 spades cards out of 52 plus 12 face cards out of 52, we can then subtract it to the number of heart and face cards, which is 3 out of 52. Overall, if you want to find the probability of event A or event B happening, or even at least one of the multiple events that may occur, you can use the addition law of probability. The second law of probability is multiplication law of probability. Let's say that I have 2 coin boxes with 6 crayons in them: red, yellow, green, blue, purple, and orange. What's the chance that I'd get the color orange 2 times in a row? Or what if Ben had a coin and a dice? What's the chance of him tossing the coin as tails and rolling a 4 on a dice? These questions can be answered if we use the multiplication rule of probability. So if we're interested in finding out the probability of 2 or more events happening together, we can use the multiplication rule of probability. In this case, we're going to look out for the independent and the dependent events. So going back, if I wanted to determine the probability of me getting an orange from the 2 coin boxes, we have to find the probability of event A and B happening together. In this case, the probability of event A is multiplied by the probability of event B. The probability of getting an orange in the first box is 1 out of 6, and the same goes for the second coin box. Now, by the multiplication law, we can multiply 1 out of 6 by 1 out of 6. Therefore, across all 36 times that we place and get a crayon out of the 2 crayon boxes, one of them is a chance that we could get both orange crayons. This is an example of an independent event. Independent events are outcomes of an event that doesn't affect the outcome of the other. While dependent events are outcomes of an event that affects the outcome of the other. In other words, the multiplication law to this is that the probability of a dependent event happening together is the probability of event A happening multiplied with the probability of event B given that A had already happened. For example, remember Harry? He's back, and now we're all left wondering what's the probability of him drawing an ace, hold onto it, and draw a queen. We'll start by finding out what's the probability of drawing an ace. In a deck, there's 52 cards and 4 aces, so Harry's probability of drawing an ace is 4 out of 52. Now, the probability of drawing a queen is different because Harry had already drawn an ace. There are still 4 queens left but only 51 cards remaining since Harry had held onto the ace. Now, our probability for this is 4 out of 51 cards. If we calculate and multiply both of them together, Harry has 16 over 2,652 or 1 in 167 chance of getting both an ace, hold onto it, and get a queen. All in all, if you want to know the probability of event A and event B happening, the multiplication rule of probability is best to use. Just be careful to look out and differentiate between the dependent and independent events. Lastly, the third law of probability is the complement law. The complement law states that if we have an event, then the outcomes of its sample space that is not part of the said event is its complement. For example, we have a box of crayons with red, yellow, green, blue, purple, and orange in it, and our event is getting a red or a yellow crayon. Then the complement of this event are those that we are not getting, namely from green to orange. We denote the probability of an event as P of E, while the complement of an event as P of E prime with an apostrophe. There are things that we need to note when we're dealing with the complement rule of probability. So, going back with our crayons, we know that each of them has a probability of 1 over 6, and if we add them all together, their sum is 1. We can then say that the probabilities of all outcomes in the sample space is 1 or 100%. So this equation is followed. So for instance, if we have the probability of an event which is getting either a red or a yellow crayon plus the probability of the complement of an event which is the green to orange, their sum is 1. In order to visualize this, we can use the Venn diagram. The area within this box is our sample space and it is equal to 1. The red circle represents the probability of an event. Outside of this circle is the complement probability of an event. So if we have 0.45 for P of E, then we can plug in the numbers and do some math, and we can find that the complement probability of an event is 0.55. And here are the equations that you can use in order to find each of the given variables of this rule. To apply this, let's say we conducted a survey in CTU and 50 people were interviewed about their favorite animes. We found that 11 chose One Punch Man, 12 chose My Hero Academia, 25 chose One Piece, and 2 chose Kamisama Kiss. And out of these people, we wanted to find the probability that a person's favorite anime is not One Piece. So then we can use the equation probability of E prime equals 1 minus probability of E to find this. The probability of the event is the people who chose One Piece over the total number of people surveyed, which is 25 over 50, and E prime is those who did not choose this as their favorite anime. So the probability of E prime equals 1 minus 25 over 50, and doing some math, we get 50 over 50 minus 25 over 50, which equals to 25 over 50 or 0.5 or a 50% probability of selecting someone whose favorite anime is not One Piece. And that's all about it. All in all, we can use these laws of probability while we're trying to find out the likelihood or unlikelihood of something happening. These laws are incredibly important, especially in our real world, because in real life, we can use these laws of probability in order to know what is the likelihood of a medicine working or how likely our situation will be if inflation rate continues on. Now, it's your turn to try. Here's a quick quiz to see what you've remembered about. Our lesson's finished. Thanks for watching. I'll see you next time. Bye!